Hello everyone, my name is Gaurav Arora. I'm a faculty of economics at IIIT Delhi, and I'm pleased to introduce this course called Spatial Statistics and Spatial Econometrics. This course will provide training on the analytical framework that is required to analyze spatial data. The course will have a twofold focus. We will learn to model jointly distributed random functions that comprise spatially related variables for statistical inference and prediction. We will then take this characterization of spatial patterns to the next step, where we will identify causal impacts in spatial regression models. The course will strive to have a balance of theory and practice, and we will do a detailed introduction of geostatistical data sets, popular open access sources, and modern applications. As far as the target audience of this course is concerned, this course will be useful for a broad range of academicians, economists, political scientists, cognitive psychologists, engineers, earth scientists, and applied physicists can all utilize the methods taught in this course. The course will use a basic knowledge of probability and statistics, linear algebra, and differential calculus. However, wherever these concepts arise, we will introduce them in detail. Why study spatial statistics now? Well, there is a new wealth of open access, spatially delineated, ready-to-use data sets that are out there free of cost, made available by agencies like US Geological Survey, Indian Space Research Organization, and so on. For example, there is a Bhuvan land use portal introduced by ISRO or made available by ISRO, which provides a detailed characterization of high-resolution land use changes over time for India. Now, major consulting firms, including Deloitte, McKinsey, and so on, apply spatial statistics tools for risk analysis and management. There is a large IT sector and geospatial industry that values knowledge of spatial data analysis. Finally, I want to end this introduction by giving a fun example. What you see on the screen is a map of the National Capital Territory of Delhi, and the colors on this map show you an index of the real estate market. More specifically, what you see are ward level average circle rates in rupees per meter squared. What you do sort of characterize straight away is that on the west side of this map, that is the blue circle, shows you wards which have low circle rates. The circle rates on the left, range from 25,000 to around 50,000 rupees per meter squared, whereas on the right you have this cluster of wards which show very high cluster rates going up to 3,50,000 rupees per meter squared. What we are able to see also is that low price wards and high price wards are clustered together in the west and the east, and there is a long-term sort of spatial trend from west to east, which provides us a gradient of increasing circle rates. Spatial statistics and spatial econometrics will help us characterize these patterns using mathematical models, and then go one step further and help us find explanatory stories or explanatory sort of inferences as to what causes these patterns to come about in space as we see them. That is the gradient as well as the clustering of high and low price wards together. Thank you.